How do we write a quadratic equation? 3 ways in which to write a quadratic equation. The one we'll look at today is in the form of y equals ax squared plus bx plus c. Okay, so that's a trinomial. The quadratic equation has a degree of 2. We don't spend a lot of time on degrees because we don't do polynomials as much as we do in grade 12. But the degree is just the largest exponent on the x value. So in this case, the largest exponent is the x squared, the 2 on the x squared. Okay. A second way in which we are going to write this equation is a x minus h squared plus k. They might use p and q, but I don't know. So in this equation, this is called the vertex equation because h and k will represent your vertex. And the third equation that we work with is the root equation, which is x minus r, x minus s, in which r and s will be your x-intercepts, which we'll call roots, which we'll call zeros. They're all going to mean the same thing. Okay? So those are the 3 types of equations we're going to work on over the next week and go through it. We spend a lot of time on this in grade 12. We do some factoring in grade 10. If you take ax squared plus bx plus c and you factor it, you're going to end up with a x minus r, x minus s. So we will do a bit of factoring when it comes down to it. So one of the things that we need to know, I'm going to see if I can pull this up. This might take a second. All right, let's figure out what each thing does. I understood how that happens. Pretty cool though. Puppy dog. Okay. All right, so looking at the first thing. The first thing that you need to know about is what happens if a is greater than 0 or a is less than 0. So if a is greater than 0, well, actually, first of all, we'll put a title here. What is the name of the shape? That's the name of the shape. So a affects the graph by 2 reasons. The first is it determines whether or not the parabola opens up or the parabola opens down. The parabola is a U shape. We'll talk about the characteristics of it in a second. So let's just have a quick look now. So first things first, y equals x squared. Yes, today it's decided to work. Lovely. All right, okay. So that is the shape that's made by y equals x squared. The value that's in front of the x squared, the coefficient, the number that's in front of the x squared is your a value. In this case, if you don't see it, it's 1. All right, it's not 0 because if it was 0, then there wouldn't be a graph there. So it's 1. Now it opens up. So what happens if I change that to y equals negative x squared? There's what you get for your second graph. The graph opens down. Okay? So the first thing you want to determine is A determines whether or not the graph opens up or down. That's what A does. The second thing A tells you is how wide or how narrow the graph is. So if I look at a third graph, I'm going to look at y equals 3x squared. All right, what's the coefficient in front of the x squared? It's a 3. So what do you notice about the green graph compared to the red graph? Skinnier, it's narrower. It goes up much faster. Okay, so I'm going to have a quick explanation of that now. You don't need to write this down. These are my 5 key points that I pick up. So the first graph, y1 is going to be x squared. So I'm going to put minus 2 in for x squared. What's minus 2 squared? 4. Minus 1 squared? 0, 1, and 4. Okay? So there's the first thing. Now, the second graph I'm going to have is y equals 3x squared. So why is it skinnier then? Why does it go up faster? Well, what am I doing? I take my x value, I square it, and then what do I do to it after I square it? Multiply by 3. So now this becomes 12, 2, 0. Oh, this math. 12, 3, 0, 3, and 12. Hence the skinnier graph. Okay? Now, if it's a fraction, y equals 0.5 x squared, this blue right here, what happened to the graph there? It's wider because it's going to go up slower because now I'm taking my x squared value and I'm timesing it by 0.5. So rather than multiply it by 3, so in this case, my blue graph, y3, it would be 2.5, 0, 2, 0.5, 2 mixed up here, 0.5, and 2. So that's why that graph goes wider now. Okay? So A determines two things. Number one, whether the graph opens up or down, and number two, how wide or narrow it is. Excuse me. Okay? Now, I'm going to go into everything right now. In the form y equals ax squared plus bx plus c, could you tell me what the y-intercept is in that equation? What's the y-intercept in that equation? B. How come it's B? Okay. But why was it B? Let me ask you two questions. Number one, on a graph, how do I determine where the y-intercept is? Where it crosses the y-axis. Beautiful. What is the x value along the y-axis? 0. So if x is 0, what is 0 times m? And then I add b, what do I get? It's b. So that's why the y-intercept is 0 and b. What about y equals ax squared plus bx plus c? What is the y-intercept for this one? C. Very good. That's the first thing I wanted you to pick up. That c value will represent your y-intercept. All right? So we can write that down. It's a good idea. C is your y-intercept. Okay, and I'm going to come back to the B part in a second. I'll come back to it. But what I want to do right now is I want to write out what all of my properties of a parabola are. Okay? So the next thing we're going to do is I'm going to take a graph. Don't write this down. I need to do this in my head. Okay. Write that down. Not yet. Not yet. You will graph this in a second. Okay? So I have that there. Okay, so just quick look. This is a much cleaner graph than what I did. But that's what the parabola looks like from the equation, x squared minus 4x plus 6. First question is, which way does it open? Up. Okay, simple enough. Simple enough. All right. Now, this guy right here, 2 and 2, is what we call the vertex of the graph. So the vertex is right where the turn happens. It's going to be either your maximum or your minimum value, depending on whether the graph opens up or down. Okay, so here's what we're going to do next. We are going to write out what the vertex is and all of the information we get from the vertex. In this graph, my vertex is 2 and 2. Again, it is this point right here. All right. It will tell you what your maximum or minimum value is. In this case, if it opens up, that means that all the y values are greater than that vertex. Therefore, the y value of the vertex is a minimum value. All right? So what's the y value of the vertex? Well, it's the same as the x. So it's a 2, right? Right here, that 2. Okay? Where are all the y values found? All above it. So then that means in this parabola, that 2 is the minimum value. If the graph opens down, the vertex will be a maximum value because all of the y values will be less than that. Okay, and I'll show you that in a second. Well, I may as well show it to you right now. Why not? Okay, so my vertex is right there. It's 2 and 0. In this case, it would be a maximum value. The maximum value being 0, because all the y values are less than that. All right. Next, there is an imaginary line drawn through here, through the vertex. There's an imaginary line drawn through the vertex. What it does is it divides the parabola into 2 equal symmetrical parts. That means on both sides of the parabola, oh, wrong one. So you can see this line drawn here, and that the parabola goes up the same rate on both sides of it. Okay? Now I want you to see something. 2 and 2 is right here. My y-intercept was 0 and 6 for this. 0 is 2 to the left of that, correct? If I go 2 to the right of that, I should hit 6 again. So 2 to the right is right here. Right there. 4 and 6. Because it's symmetrical, the distance away from the vertex is going to be the same on both sides. The y value will also be the same at that point because it's symmetrical. All right. This line, this imaginary line, has a name. It is called the axis of symmetry. And what you need to know about the axis of symmetry is what is the equation of that line. What is the equation of that line? I want the equation of the line that divides it into 2 equal parts. It is x equals 2. It will always be x equals the x value of the vertex. It will always be x equals the x value of the vertex. I'll get to that in a second, a little bit more. Okay? So there you have the axis of symmetry, the vertex. Then we got to look at the domain and range. What's the domain for this graph? Go ahead.
The domain.
Yeah.
So it's infinite. We can go up.
Okay, how do we describe that though? Say that again? No. Now, in grade 10, I showed you two ways in which to describe the domain and range. Set notation and interval notation. Okay? You can choose whichever one you are comfortable with. How far left does this go? What is it? No. How far left? Yes. Negative infinity. How far right? Okay, so if you wanted to write this domain as negative infinity to positive infinity, you can. That's fine. I think this is the way that you would write it more often than not. X is an element of all real numbers. That's all left, all right, every number in there, continuous graph, the whole bit. X is an element of all reals. Okay, so whichever way you like to do it, that's up to you. Okay, now let's look at the range for this graph. In words, describe the range of this graph right here. Where are all my y's located? Above 2. Okay, so my range are all the y values above 2. Okay, all right. So using this notation here, first things first is I always put the lowest number. What's the lowest value on there? 2. Inclusive or not inclusive? Square or round? Square. Right on. Well done, guys and gals. Mostly gals, less guys. 2. 2. Positive infinity. There's one way to do it. Okay? The alternative,
We don't want the alternative.
y is greater than or equal to 2. I like to add this in at all times. Y is an element of all reals, but y is greater than or equal to 2. That's your range for that graph. Okay, if it doesn't include the value, which can't include infinity, I put rounded brackets. If it includes, I put square brackets. Okay? So the 2 is inclusive here for the range because the graph goes directly through 2. So 2 is included, so I put square brackets so that the person knows that 2 is including it. And infinity is always round brackets because you can't actually include infinity. Okay, so far so good. So my vertex, going back to my vertex tells me the equation of the axis of symmetry, x equals whatever the x value is. It tells me whether it's a maximum or minimum value based on whether it opens up or down. If it opens it down, it's maximum. If it opens up, it's minimum. And it also tells me the range each time. The y value will tell me the range each time. Go ahead.
So what is the a?
The a is the coefficient in front of the x squared. So far, so good? Okay, so I'm going to switch this up now. Now, one of the questions in the book says, what happens when you adjust b? So here's what I'm going to do. I'm going to take this equation. I'm going to go y equals, and we'll play with it for a second, x squared plus x plus 3. Okay, So first of all, looking at the equation, y equals x squared, you don't have to write that down. I'm going to just play with it and show you how it adjusts. We don't do a lot with B. We focus on A. We have less focus on C. And B, we have less focus than that. Okay? But let's just see what happens to the graph when I adjust what B is. So B is the number in front of the X. Currently, what is the number in front of the X? 1. So let's see what happens when I change it. Okay, so going back to this, y equals x squared plus x plus 3. What is the y-intercept? 3. Okay, so let's change this up. Y equals plus 3x, oh, sorry. It's all wrong. Y equals x squared, add 3x, add 3. Okay. What happened to the graph? The red was the first, the blue was the second. What happened to the graph because I changed B? Pardon me? Yeah, I changed the vertex. Didn't it? The vertex here is that. The vertex up here is that. So we moved the vertex. Okay, let's try this again. Let's go. Y equals x squared minus 3x. Add 3. What happened here? Moved the vertex to the right. So by making it a negative, it moved the vertex to the right. By making it a positive, it moved it to the left, which is kind of opposites. But that'll be something important to you as we go ahead. Opposites matter when it comes to graphing. Okay, so that's it. That's all there was to 7.1. 7.2 goes through everything I've done already. Let's go to the example on 7.2. Says determine the y-intercept, any x-intercepts. The equation, the axis of symmetry, the coordinates of the vertex, and the domain and range of the function. Okay, f of x equals. Again, f of x equals, f of x is just another name for y, but it's telling you what? What does that, because it's an f of x, what does that mean? What does that mean, f of x? It's a function, which means it passes the vertical line test. Okay? That's all that means. Otherwise, you can just write y there if you want. It means the same thing. Okay. All right, so first of all, does it open up or down? Down. How come? In front of the what? There you go. Good job. It's a -1 in front of the x squared, so it's going to open down. What's y-intercept? 8. Okay? Basically, that's all you can tell from this, the way it's written. That's it. Now we have to graph it to get all the other pieces of information out of it. Okay? We can't do anything with it in that form. We eventually will learn how to change the form so it works better. But in that form, that's all we can really get. What A does, what C is. Okay, minus x squared. What was it? Minus x squared plus 2x plus 8. Thank you. Okay. All right, so it opens down. We got that part. What is the vertex of this graph? 1 and 9. Perfect. Okay. Y-intercept we see is 8. We had that already. Okay. X-intercepts. X-intercepts are right here. There and there. Those are the x-intercepts. Again, in that form, I can't easily see what the x-intercepts are. However, while we're here, I may as well show you how this is going to work. What is the y value for the x-intercepts? 0. Okay, so let's have a look at this. I'm going to put 0 in for y, and I've got to solve for x now. Okay, now you can just use your graph to do it, but we need to refresh on how we did this. Okay, so the first thing that I'm going to do is I'm going to multiply by -1. I'm going to multiply everything by -1. That still gives me 0. That gives me x squared minus 2x minus 8. All right, I never like using a value in front of the x squared if I can help it. So now we got to factor it. 2 sets of brackets. What are the factors of x squared? X and x. What are the factors of -8 that add to give you -2?
-4 and 2.
-4 plus 2. Okay, so back to the factoring we learned about last year. So now, x minus 4 equals 0. X add 2 equals 0. X is equal to 4 and -2. Those are my x-intercepts. So without graphing them, by plugging in 0 for y, because that's what the y value is on the x-intercept or on the x-axis, I can get 4 and -2, which is what I had down here. So you can use Desmos, you can check it, and you can see that you've got it. 4 and -2. Those are my x-intercepts. Y-intercept 0 and 8. X-intercepts -2 and 0, 4 and 0. So far, so good? Okay. What is the equation of the axis of symmetry? Not 0. Which one is it? X equals. What is the vertex?
Oh, yeah.
Okay, you looked at the y-intercept? Okay. There's your x value. Your equation of your axis of symmetry. The equation of the axis of symmetry is x equals 1. What's the domain for this graph? Sure.
So like, will it always be continuous on Desmos? Because like they don't have arrows.
Okay, that's an excellent question. You must place arrowheads at all times.
They're always
Always continuous. Okay? The only time it won't be continuous is if you have a word problem in which you aren't using maybe the negatives or something like that. But every time you graph an equation such as this, you're going to have a continuous graph, and your domain, you guys are fighting me on this. I don't like this, but I'll accept it. I like that better. X and all reals. Doesn't matter. You're right, I'm right. I'm more right than you're right. Okay. Somebody, give me the range.
less than 9 and 2
Okay.
Less than or equal to negative. Less than or equal to 9.
Okay. How do we want to write it? Range. Now what?
Square bracket 9. And then comma negative infinity.
We agree? Yeah? Anybody want to disagree?
What? Is that included?
What's the problem with this? What is the lowest number?
Oh, it's up from, yeah.
Always needs to go from down to up, lowest to highest. Therefore, that's right. If I do it the other way, then it means that the 9 is the lowest and the infinity was the highest. So it's negative infinity up to 9. Includes 9?
Yeah.
Yes.
So would it ever not include it?
No. Okay? Making out all right here?
Yeah. Exactly.
Last thing. Okay. Again, and this actually, I don't even have to go through it. I'll go through the example on 7.3, but roots. There are 3 possibilities. Okay, first of all, let me write this down so that you understand what that means. These roots, x-intercepts, zeros, all mean the same thing. The book might ask you for roots. The book might ask you for the x-intercepts. The book might say, what are the zeros? They all mean the same thing. That is where the graph crosses the x-axis. Okay? In that equation, where does the x cross the x-axis? Negative 2 and 4. So you have 2 roots here. So there are 3 possibilities on roots. This just sums up what that other one is. You can have 0 roots. Maybe your graph opens up and never crosses the x-axis. You could have 1 root in which your vertex is on the x-axis. So if your vertex is on the x-axis, there is only 1 root. And then there's a possibility of 2 roots. If it's below the x-axis, your vertex, and it opens up, or if it's above the x-axis and it opens down. So you have 3 possibilities for roots. 0 roots, 1 root, 2 roots. Here, this y equals negative 4.9 x squared plus 19.2 x minus 5.2. Now you're going to notice on there, you're going to notice on the equation is done a little bit different because it's given to you as minus 4.9x squared plus 19.2x minus 5.2 equals 0. So all you are doing theoretically in this question is solving for the roots. All right? Today, you just need to graph to solve for the roots. Even though I showed you factoring, this might be a question in which you would factor. But there's root 1, there's root 2 to 3 decimal places. 0.293 is root 1, 3.626 is root 2.
Go back to that.
That's all you need for roots. Right here and here. Okay? That's it for today. So we want to get through 7.24 tomorrow. Yeah.
Can you explain factoring again?
Can I explain factoring again? Sure.
Yeah, great, my job.
All right, let's go through. All right, let's do this. X squared minus x minus 6. If the a value is 1, the first thing, actually, let me do this different. Just for one, I'm just going to just change one thing, one aspect of this. That is 12, that's 2, and that's 2. Okay, I'm just going to start like this. Okay. First thing we do in factoring. What is the very first thing that we had to do in factoring? What did we look for? Say again? Yeah, okay. The first thing you do in factoring is look for the greatest common factor. Is there a greatest common factor here? 2. So we take the 2 out of here. So that's the first thing that you do in factoring. Now, once you have the value, the coefficient, the A value in front of the x squared is a 1, then I just need to do 2 sets of brackets. So I go 2, bracket, 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 bracket. What goes in the first part of the brackets? X and x. The factors of x squared. Now I need the factors of -6. What do you multiply to get -6 to add to give you -1? -3 plus 2. And it's done. I need the factors of -6. I'll write that over here. That add to give you your middle term, which is -1. Factors of -6 that add to give you -1. Okay? Let's try a different one. What is my A value? What is it? 1. So now I just need 2 sets of brackets. Factors of x squared. X and x. What do I multiply to get -40 that adds to give me -3? 2 factors of -40. Our girl, good job. -8 plus 5. If you struggle with your multiplication table, this becomes an issue. Because you got to be able to find factors quickly. All right? Okay. A couple more of those. Sure, you want one more? All right, let's do one more. I feel more comfortable. X squared minus plus 2x minus 6. My math works. No, that's not right. Okay. A value is 1. Factors of x squared. Factors of -63 that add give me 2. Excuse me. Say that again. Perfect. So far, so good? Okay. All right, I'm going to give you one more here. So I got to do this in my head.
Gonna be like bigger than that, or no?
Yeah. In terms of this, let's go 2x squared. Don't write this down yet. All right. Okay. Okay, so now we have to do something entirely different. I do something entirely different here because, first of all, we look for a greatest common factor. Is there a greatest common factor?
No.
Negative. Okay. So now I can do two sets of brackets. If you are confident in your factoring, you can do it here. But most of us aren't quite there. So my product is whatever A times C is. So instead of the factors of negative 63, now it's the factors of negative 12 times 2. So negative 12 times 2 is negative 24. I take the A value and I times it by the C value. The sum is negative 5. That stays the same. So I need factors. Again, I'm telling you this is going to be completely different than what we've done up to this point. I need the factors of negative 24 that add to give me negative 5. Okay. Isla says negative 8 and plus 3. Okay. Now, I use those factors and I place them in the equation where the sum is, where the middle term is. So I replace the middle term minus 5 with minus 8x and 3x. Yes. 2x squared minus 8x plus 3x minus 12. So again, I replace the middle term with the two factors. Anybody remember what to do next? Brackets. All right, good. So brackets around the first two terms and brackets around the second two terms. Now it's greatest common factor time. So what is the greatest common factor between 2x squared and minus 8x?
2x.
2x. So I'm going to take the 2x out. I'm going to factor it out. I'm going to divide it out. So what does that leave me with? X here, subtract 4. Okay? Plus. How about over there? Greatest common factor?
3.
3. Take it away from there, factor it out. X subtract 4. Now at that point, I know whether or not I got it right because the two brackets have to be exactly the same. So if the two brackets are the same, whatever's in those two brackets goes in the first bracket down here. So x minus 4 goes here. What am I left with when I take an x minus 4 out of these two guys? 2x plus 3. All right, it's coming back to us now. No.
What's standard form?
Ax squared plus bx plus c.
Okay.
Okay? Now, we don't have we don't have to do any factoring yet. So you have a day or two, probably the weekend, to kind of look back at factoring. The factored form, they will factor in 7.4. Okay, so 7.1 to 7.3, you can work on that. It's all Desmos work. Okay? All right. That's it. That's all, folks.
Do you want to